Welcome to another exciting educational video brought to you by Vision Concepts Academy. In this video, we'll be looking at reflection of light by curved or spherical mirror. We looked at the reflection of light on plane mirror in the last video, and we'll be moving up a step further to see how light rays behave in spherical mirrors. So in this section, we shall consider only curved mirrors which form parts of spherical surfaces. Such mirrors include spherical mirrors like the one we use in the science lab, shaving mirrors, car driving mirrors, parabolic mirrors of telescope, mirror reflectors, and searchlights are such applications. But before we dive in, let me just conclude what we did in the last video by discussing about images formed in inclined mirrors. Images formed in inclined mirror. So we are still just quickly going to just consider this aspect. You see that for plane mirrors that are inclined at an angle, let's say this one plane mirror, and another one inclined, that's two, inclined at an angle theta. Understand? The number of images formed by this mirror, these two mirrors, is equals to 360 over theta, where theta is the angle in between the two mirrors, minus 1. So for example, if two plane mirrors are inclined at 60 degrees, the number of images formed by those two mirrors is equals to n is equals to 360 over 60, which happens to be theta, minus 1, which is 6, this here 1, this here 6. So 6 minus 1 is equals to 5. So 5 images are formed when two inclined mirrors are inclined at an angle of 60 degrees. So you can solve for many other cases. Okay, so that's the first consideration. Secondly, we will consider the effect of mirror rotation on a reflected ray. So you call it mirror galvanometer. So let's just see how that turns out. So if, for instance, we have a mirror like this, stationed at this plane Pn, and you have angle of incidence, maybe on it like this, incident ray, this is the incident ray. So if this mirror is pulled down this way, I pull it down this way, so that it now rotates. If I pull it down, it goes up, and there's an angle that is formed like this, angle of rotation. Understand? So when it happens like that, this reflected ray, the reflected ray is now equals to 2 theta. Angle of reflection is equals to 2 theta. So whenever there is a tilting of the mirror, the incident ray is still constant. Understand? If the incident ray has constant direction, understand, and the mirror is just rotated an angle theta, the reflected ray is rotated through an angle 2 theta. That's why we have it like this, 2 theta. Okay, so having considered that, let's just go to the meat of what we have for today. The video is going to be exciting because we're going to be looking at the world of curved or spherical mirror. So a curved mirror actually is like a mirror that is curved. There are two types. This is a mirror. I told you mirror is just a glass that has a coating at the end. So this is a mirror. This one that is curved inward is the concave mirror or the converging mirror. Converging mirror. And the one that is curved outwardly like this is known as the convex mirror or the diverging mirror. So these are the two kinds of mirror that we have. So we're going to be discussing the parts of these mirrors, the parts of the mirror, the curved mirror. So we have the aperture. The aperture is AB. Aperture is AB. Now there is an imaginary line that runs on the center, and we call this line the principal axis. The principal axis. The principal axis. So just an imaginary line that runs through the mirror. Then you have a point here on this principal axis called C, and it is called the center of curvature. The center of curvature. Let me just put the terms outside. Center of curvature. That's C, labeled here. Then you have a point here, F, called the principal focus. The principal focus. The principal focus. F, that's point F. So there's a point here, P, it's called the pole. Pole is point P. And A, B is the aperture. The aperture. Okay, so the distance between C and P, R, is called the radius of curvature. Radius of curvature. The radius of curvature. So it's called it R. Okay, now definition of these terms. So the pole is actually the center of the reflecting surface, the reflecting mirror. The pole is the center of the reflecting mirror. C is the curvature, center of curvature, is the center of the sphere of which the mirror forms a part. So if, for instance, now, like I said, this is a curved mirror. Actually, if you extrapolate this like this, see where my hand is going. There's a circle, there's a sphere that is being formed. So this C is the center of that imaginary circle, though this is just a part. So the center of curvature is the center of the sphere of which this mirror forms a part. This mirror forming a part. Now the principal axis is just the line that is dividing this mirror into two equal halves. Okay, so the principal axis is this line. This is the principal axis. I've labeled it already. Principal axis. Okay. So now the principal focus F. Principal focus F. This principal focus is the point in this concave mirror where rays parallel to it appear to converge after diversion, after reflection. So if, for instance, now I have rays, I will just do maybe two. This one like this goes in like this, and this one goes like this. Once it hits here and reflects, you understand, there is a point where it appears to converge after reflection. So the principal focus of a converging, that's why we call it a converging mirror or a concave mirror. So it's the point where incident rays parallel to this principal line, where incident ray parallel to this, hitting this, appears to converge after reflection. So the principal focus of a converging lens is defined as we have defined it. Converging mirror, sorry, lens is different. We'll come to the lens later. But for the diverging, this is diverging. So it's labeled like this. This is P here outside. I have F here. and I have C here, where F is the principal focus and C is the center of curvature. So for diverging lengths, this diverging, the principal focus is the point where rays parallel to the principal appears to diverge after reflection. So if a ray is like this, it diverges, it reflects, and there's divergence. But the divergence actually comes if you extrapolate this one down. I said that light follows straight line. If another one comes like this now and reflects, this is incident, it reflects out like this. It appears to come from this place. If you continue it, actually there's a virtual image formed here. So the principal focus for a diverging mirror is the point where rays parallel to the principal appears to diverge after reflection. So it's diverging from here, but normally it goes like this and reflects, goes like this and reflects. But if you extrapolate the reflected ray backwards into the mirror, there's a point where they meet. That point is the focal point. The focus is the point which rays parallel to the principal of a diverging mirror appears to diverge after reflection. Okay, now having gotten the whole of these terms, there is a way you can relate images and objects, the way it forms image and object. So we're going to quickly go into how image and objects are formed on these mirrors, both converging and diverging, or concave and convex. Please note the names of these mirrors. Note the names of these mirrors. So the one that is concave is converging. The one that is convex is diverging. Okay, so if I will draw this thing again. I will start from the concave mirror. So if I have the concave mirror like this, let me just, I would just utilize this space like this. So I have a concave mirror like this. So I'll just show here that it's concave. Then I have my principal axis. So I label it now. This is my point P, F, and C. Point P, F, and C. So if I have an object placed beyond C, if I have an object placed beyond C, what happens to the image that is formed? So I'm going to use ray diagrams to explain the phenomenon. So the ray of light from the top of this object, normally if you see arrow like this, that's the head of the object, the head, understand? So the ray hits the mirror like this, and normally it tries to converge through the focus, and the ray of light also goes through the center of curvature. For center of curvature, when the ray goes through it, it still comes back through it. The center of curvature, that's its nature. When the ray of light goes through center of curvature, it comes back through it. But when the ray of light hits the mirror, it converges on the focus for converging length, or diverge from the focus for the diverging length. Okay, so this is for the concave. So if I say object placed beyond C, that's the scenario. Object placed beyond C in a concave mirror. So these are the characteristics of images formed on the concave mirror. So where these two rays intersect is where the image is formed, and it's formed like this. Now look at what happened. This first ray hits the mirror and reflects. It reflects and passes through the focus. Second ray passes through the center of curvature, hits the mirror, and go back. Now there are many rays are interacting like this, but we are taking the ones that can make you to understand what is going on here. So the incident ray on the tip of this hits the mirror and reflects through the focus, and the second one hits goes through the center of curvature, hits the mirror and go back. So the image that is formed here, characteristics: one, it is inverted. Image form, inverted image, you see it's upside down. Diminished means that it's smaller than the object. Diminished means that it's smaller than the object. Diminished means that smaller than the object. It is real image. Why? Because it is formed in front of the mirror. Real lines are interacting to get the image. So it is formed in front of the mirror. Okay, so these are the characteristics, and it is formed in between F and C. Formed between F and C. So they can ask you in your exams, what are the characteristics of the image that is formed when the object is placed beyond C in front of a converging lens, a mirror, or a concave mirror? So one, it is inverted. Two, it is diminished. Look at it, smaller. Three, it is real. And four, it is formed between F and C. So this is kind of question, they can even use it. They can even ask you which of the following is not the characteristic. So they will put this incorrect like this and put one thing that is not correct. So that is for object placed beyond C. First scenario. Second scenario, object placed on C. Object placed on C. Object placed on C. So I'm going to draw my mirror again. This is my mirror. I'll draw my mirror. Then I'll draw the principal axis like this. And I'll put this C, F, and P. So I'll place the objects on C. So the ray of light hits the mirror like this and is reflected through F. And this one goes through F again and reflects back and forms the image here. Okay, so this object and this image. Now, characteristics of the image form here. The image form here, number one, it is inverted, upside down. It is same size as the object, same size as objects. Then it is real again, it is real, and it is formed on C. Formed on C. What is C? C is the center of curvature. Again, we have four characteristics: inverted, same size, real, and formed on C. Now I'll have another scenario where the image is placed between C and F. So this is my convex mirror. Sorry, my concave mirror. Concave is caved in. Concave is caved in. Caved, concave is caved in or converging. The rays converge on the focus. Okay, so I have C again, my point C, F, and P, and I am putting objects between C and F. Object scenario is object between C and F. So I'll put beyond C on C and between C and F. So my object will be here. Okay. So the object, the ray goes hit the mirror like this and reflects through F. Goes like this. And this one ray will hit here like this and still reflect back and pass through C. Sorry. I need to extend this up because there's a way it should pass. Pardon my space management from the board. So it will hit here. Actually, it's going to pass through the center of curvature like this and go and hit somewhere here. Okay, so this is it. Okay, so it passes through. So there's going to be an image formed here. Very big. Look at the image. Big. So you see the rules. The rules is that the reflected ray will either pass through the focus or pass through the center of curvature. So for this particular scenario where the object is in between C and F, the first reflected ray goes through F, then another one will go through C this way. Understand? Go through C this way. So the geometry is straight like this. So these two lines will meet. Where they meet, where these two reflected rays are meeting, Understand? They are forming an image there. This one is still inverted, magnified. So at this point, I'm getting the object bigger, sorry, the image bigger than the object. So this one is magnified, it is real, and formed beyond C. Not beyond C. Beyond C. Beyond C. Beyond C is center of curvature. Behind center of curvature. So I have the image formed behind the center of curvature. All right. So another scenario is when I have the objects placed on F. Okay. So I will have this like this. Object placed on F. So this is P, this is F, and this is C. So this is the object placed on F. So I have the ray hit the mirror, reflects through the focus. Another one will also reflect through the center of curvature. But this thing will continue like this. We never meet. We never meet. So it will go and form in infinity. So image is also inverted. Characteristic of image form is inverted. It is magnified, yes, because it's going to be very big, magnified. It is formed at infinity, inverted, magnified, formed at infinity, and is real. Any image formed before the mirror for concave is real. So for infinity, is real, inverted, magnified, and formed at infinity. And the last scenario for concave lens is when what am I calling lens? We are going to do lens. We are still a mirror, spherical mirror, but this is spherical mirror. Okay, so for spherical mirror, the image formed when the object is placed on the principal focus, it is formed at infinity. So the last scenario is when the image is placed between F and P. So we're going to look at that scenario quickly. So object placed between F and P. So I will draw it like this. Okay, let me just reconstitute. Okay, so this is the mirror. So object placed between F and P. So this is CFP. Okay, so I place my object here. So what happens is that when the ray of light hits the mirror like this, it's reflected to the focus. Then for this one, ray comes like this, hit this one, but it will now continue here virtually because it must meet somewhere. So it meets here. Where it meets, it now forms the image. So the image, for the first time, we have upright, also magnified, bigger than the object. We have it as virtual. Why? Because it's formed behind the mirror. See these broken lines? Formed behind the mirror, and it's formed behind the mirror. So it is very important that we know how to get these characteristics, so that for all these objective questions where you are just told, given a scenario like this, and they tell you to get the answer, which one is possible or correct. So they will give a scenario. Object is placed between F and P. How is the image? Describe the image. It could be even essay type questions. Describe the image, so you know how to get it. Okay, so that is it. But for the convex mirror, there's only one scenario for the convex mirror. Haven't gotten all the scenario for concave. only one scenario for the convex mirror. So I'm going to put it on the board for us to see. Only one scenario. Okay, so for the convex mirror, we see that the mirror goes in like this. So this is the reflecting part is the one that is curved outward. So this is the pole, the focus, and the curvature. So object is placed anywhere here, whether you place it close or place it far. No matter how you place that object, you understand? The thing is that the ray of light hits this like this, and we say that it reflects, but it appears to diverge from the focus. So that's it. Then another one, we go and pass through the center of curvature like this way. So the image is formed in between F and P, always. It's formed in between F and P, and in nature, characteristics is that, okay, this was the scenario here. The scenario is objects placed in front of a diverging mirror. Okay, so what are the characteristics of this image that is formed? Number one, it is diminished. It is diminished. It is virtual. Why is it virtual? Because it's formed behind the mirror. Broken lines. It is diminished, virtual. It is upright, and it is formed between F and P. So these are the scenarios. Of course, the focal length is determined in the lab through a method. We're going to look at that in the next video. I hope this video has been informative for you. I'd like to thank you for viewing.